I will explain some basics related to functions, right? So can you tell me what do you mean by function? Hmm? Why we are writing a functions? Tell me. Always we are writing some functions, right? Up to your O level, you learn different functions, right? So you have some experience with functions, right? Can you tell me what is the purpose we are using functions? Anyone? Any volunteer to answer my question? So what did you understand by function? Tell me, what did you understand by a function? Yeah, functions means uh, if you just imagine, right? Okay, y is equal to 2x plus 1, right? This is a function, right? This is a function, right? So functions means we can find out the relationship between the variables, right? So y is a variable, x is a variable, right? Depending on the value of x, how the y changes, right? So that is a relations between two variables, x and y, right? This x we can say independent variable, right? This is an independent variable, right? Independent means it is not depending on any values, right? It's independent. That's why we are saying x is a independent variable. Why we can say this is a depending variable? This is dependent variable. Why we are saying y is a dependent variable? Depending on the value of x, always the value of y will change, right? So sometimes we will define a function with f of x. So this is one way we can define a function. Or sometimes we will define a function with y is equal to, right? So maybe you can define f of x is equal to 2x plus 1, right? This is also one way we can define a function. This is another way we can define a function. So normally we are using y or f of x or g of x or h of x. These terms we are using to define a function, right? So within these parentheses, this is the variable, right? So this is we can call the independent variable, right? This is a variable x. This function will change depending on the value we are putting for x, right? So you just imagine you have a function g of y, maybe g of t, right? Now, can you guess a function for this? So g of t is a function. So the variable is t, right? So the value of t will always change, t squared minus 5 or something, right? So this is the one relationship between uh, t, right? So depending on the variable t, the values are changed, right? If I put t is equal to 1, then g of 1 is equal to 1 squared minus 5. So 1 minus 5 is equal to minus 4, right? So similarly, if I put t is equal to 2, then g of 2 is equal to 2 to the power 2 minus 5. Then the value is 4 minus 5 minus 1, right? Then if I put t is equal to 3, g of 3 is equal to 3 to the power 2 minus 5, 9 minus 5, 4. Likewise, what will happen depending on the value we are put for the variable, the depending on the value we are putting for the variable, the function will change. So functions means the relationship between the variable, right? So that is a normal form, right? Maybe you learn in your O levels, you plot the function, right? Quadratic equation, right? So y is equal to x squared minus 5x plus 1. So maybe they will ask to draw the uh, graph, right? So this is a function. So they will ask you to draw the graph, maybe this one or this way. You can draw. You have some experience, right? So functions means we will define the relationship between the variable, right? So this is a very basic in mathematics, right? So we are using these functions to all the places, right? So just imagine we have a function that define the velocity, right? So the velocities, we have an equation, right? The distance over time, right? So this is a function, right? Similarly, for different places, we can create functions to define or to find out the relationship between the variable, right? So maybe for functions, we can call different names, right? Maybe we can say mapping between the variable, or map or transformation between the variable. Different names we can call functions, right? Okay, if I put another definition for function, right? A function is a, uh, just read this. Function is a relation between set of inputs, right? So you have a set of inputs. Just think about previous case, f of x is equal to x squared minus 5, right? So this is a function, right? So set of input means what are the values we can assign for x, we can call as a input values, right? If I put x is equal to 1, or if I put x is equal to 2, these values 1 and 2 are, we can say, inputs, right? So we have a set of inputs. Then for these inputs, we have a set of output, right? It means if I put 1 for x, I'm getting a value for f of 1, right? So f of 1 is equal to 1 minus 5 minus 4. So minus 4 is the output. If I put 2 here, so the output is 2 to the power 2, 4 minus 5 minus 1, right? So if I put x is equal to 3, f of 3 is equal to 3 to the power 2, 9 minus 5, 4. So if you have set of inputs, right, these values 1, 2, 3 are inputs, we have some output values, right? That is also a set, right? So functions means we have a relationship between the set of inputs and outputs, right? So these inputs we can call as a domain, right? These input elements we can call domain, right? All the inputs we can call as a domain elements. All the outputs we can call as a codomain. So this is, we can call codomain, right? So inputs are domain elements, outputs are, we can call codomain. So function is a relationship between set of inputs and set of possible outputs with property that each inputs related to exactly one output, right? So the important thing here, first thing you need to find out whether it's a function or not, right? So I will explain with the diagram, right? It's easy for you rather than I am writing here, right? So just imagine, right? So already I will tell you function we can write in the form, right? So this is my domain, right? This is my domain. This is my codomain, right? So this is the function f. So this is the function f from domain to codomain. So here in the domain, we have some values, right? Maybe just think about A, B, C. Okay. Similarly, here we have some numbers or something, right? This is input, this is output, right? Maybe 1, 2, 3, 4 or something, right? So the each element A, B, C, we can say as a domain elements. This 1, 2, 3, 4, we can say codomain of the elements of the codomain, right? So function means a set of element. Maybe you can say this is set A, right? Just think about this is set A, right? This is set B, right? So the function means each element of set A, we need to assign unique element of set B, right? So this is set A. This set A is a domain. Set B is a codomain, right? So set A is a domain, set B is a codomain. Right here, what we need to do, we need to find a relationship. Right, in the previous case, f of x is equal to x squared plus 5. Right, just imagine this is a function. Right, f of x is equal to x squared plus 5. Right, just imagine A is a 1. Right, B is equal to 2, C is equal to 3. Right. So now tell me what is the value for f of 1? So if I replace for if I replace by x is equal to 1, now what will happen? F of 1 is equal to 1 plus 5, 6, right? Similarly, for x, if I replace for 2, f of 2 is equal to 2 to the power 2, 4 plus 5, 9, right? So similarly, f of 3 is equal to 9 plus 5, 14, right? So now what I need to do here, right? If I draw the function for this one, so my domain, right? In the domain, I have 1, 2, 3, right? In the codomain, I have 6, 9, 14, right? Now I need to assign elements. So in the function f, the function f of x, I can assign one is assigned with 6, 2 is assigned with 9, right? Maybe 3 is assigned with 14, right? Now just think about maybe x is equal to minus 1. Now what will happen? F of minus 1 is equal to minus 1 to the power of 2 is equal to 1 plus 5, 6, right? So minus 1 is the input element, right? So if I draw here the minus 1, if I draw this minus 1 here, right? Minus 1 means that value also becomes a 6, right? So this is we can call as a function, right? So you have a set of input domain elements, you have a set of output variables, output values, that is we can call codomain. Then you can find out the relationship between domain and codomain elements, that is we can call as a function, right? Okay, the definition says each element of set A in the sense this is the domain, right? So this is the domain. We assign unique element of set B, right? Set B is the codomain. So we need to assign elements from domain to codomain. That is we can call a function, right? So this assignment, we will assign the element from domain to codomain. We can this assignment we can say that is the function from A to B, right? A is called domain, B is called codomain or target set or codomain. Normally we are using the term codomain always, right? So if you look at here, right, in this example, here maybe you can assign this way, right? The domain element A have a relation with 2. Maybe the domain element B have relation with 1, right? The domain element C relation with 3, right? So now we can define this function in a notations, right? In the notation we can write this way: f is a function, then you need to put the colon from A into B, right? So this is the way we can write, right? So this letter says this is a function of f from A into B, right? A is the domain, B is the codomain, right? Now if I write G is a function from C to D, right? Can you tell me which one is the domain here? So domain is C. C is the domain. D is the codomain, right? So if I write this way, you can find out which one is the domain, which one is the codomain, right? That is important, right? So whatever we are not telling in the paragraph sentence form, right? Directly I will put in a symbol, right? If you look at this symbol, you can understand I am telling here by a a function, right? So we can call f is a function from A into B, right? Maybe we can read this way, f takes or f maps A into B. Different ways we can read this one, right? So this one we can call f of x, right? So we can call this one f of x, right? We can call this one as a f of x, right? So this one we can call g of x. So these letters we are normally using to define the function, right? So maybe h of x or p of t, right? So it means p of t is a function, right? From this you can find out the variable. The variable is here. What is the variable here? T is the variable. Here x is the variable, right? Here s of x. So x is the s of x is a function. The variable is x. The changeable value x. If I change the value for x, the function will get different values. That is the thing. From the symbol you can understand, right? Okay, just think about here. This is my A. A is a domain. B is the codomain, right? Now this is the function of G, right? I can write G is a function from A to B, right? Here, let's say A, B, C is there. Here, 1, 2, 3, 4 is there, right? So maybe this is a one relation. Okay, just think about this is a function of G, right? Now, this 1 and 4, right? This one, so this 1 and 4, we can call images, right? We can call 1 and 4 images, right? Why we are saying 1 and 4 is an image? Why I'm telling this image, right? So from if this is codomain, right? So B is a codomain. In the codomain, which elements assign with the domain elements? These elements we can call images, right? So this 2 and 3 is not assigned with any domain elements, right? They are not assigned with domain elements. So we cannot say this is an image, right? All the elements which are assigned, which have assigned with domain element. So this is assigned with the domain element A. So the codomain element 1 has have a relations with the domain element A. So this is called image. So if I ask you the images of, if I ask you the images of G, images of the function G, you need to write 1 and 4, right? So 1 and 4 are the images of the function, right? How you can find out the images of the function? What are the elements of the codomain? What are the elements of the codomain which are assigned, which have relation with the domain elements? These codomain elements are we can call the images of that function. So the 2 and 3 are not images, right? So if you look at here, f assigned to A, right? What they're saying. So just think about here, A is an element of A. A is a set, domain set. Now A is an element. Then here, in this example, maybe just think about this is a function f, right? So then f of A is the element of B, right? So f of A is equal to here 1, right? So 1 is assigned with this domain element A. So f of A is equal to 1, right? This 1 is the image, right? The 1 is the image of the element A in the domain, right? So now if you have a function, right? For that function, you have a set of input elements, right? for the set of input elements. So the domain element, if you find out all the possible outputs, all the possible codomain elements, then we can call all the possible codomain elements are we can call as a range of the function, right? Range of the function, right? If you have a function, for that function, you can find out all the possible values, then we can say that is the range of the function, right? Just imagine f of x is equal to f of x is equal to okay, now just think about this is a function. F of x is equal to x squared, right? So can you find out the range of this function? Just imagine x is a positive integer, right? Just imagine x is a positive integer. Just think about x is a positive integer, right? So positive integer means starting from 1 to infinity, right? Now tell me, what about the, okay, just think about x is a natural number, or maybe x is a integer. Just think about x is a integer, right? X is a integer, right? Just they are telling x is a integer, right? X is a integer. Okay, can you find out the range of this function? X is a integer means minus infinity to plus infinity. We can put minus infinity to plus infinity. We can put all the values for the function, right? But how about the codomain of these? Even if you put minus largest value, you are getting always positive values, right? So the range starting, if you write the range of this function, right? The range of this function comes from 0 to plus infinity, right? So this is the range, right? Between this range, it will take the codomain elements, right? Why I'm telling here, even if it is a negative value it takes for the x, always it will take positive because this is a squared function, right? So if it is a minus negative value, if you get the square value, it becomes a positive, right? I want to try to request to recordings, right? Okay, I already told you, right? We can define the functions in different way. F of x is equal to x squared, or maybe some way we can write this way, right? This is also one way we can denote the functions, which but it's rarely used here. Right? Normally we are using f of x is equal to x squared, or also y is equal to x squared. These are the two ways normally we will define the functions, right? It's very rarely used this one, right? So just you can remember these are the different ways we can define the functions, right? So functions means they are mathematical formulas, right? So if you find out the relationship between two or three variable, that is a function, right? Maybe you can find out a function between your capital income as well as that your cost. So that is a formula, right? Each and every formula we can say as a function, right? Mathematical formulas we can say as a functions, right? They are created for some purposes, right? To find out the values, we are creating the functions, right? Okay, before move to the next topic, right, I will tell you some important things, right? So if I draw something, yeah, images in the sense, right? Just look at here, you have a domain, right? You have a codomain. Domain is a set, codomain also a set, right? Domain is a set, codomain also a set. Domain have some elements, right? Domain elements, right? This is we can call as a inputs, right? This is we can call outputs, right? So domain have one specific values, right? -1, 0, 1, 2, right? Similarly, in the codomain, they have 4, 3, 7, likewise 8, 9, likewise different values, right? 2, right? So it means if I input something, right, they have some output, right? So image means only we need to think about the elements of the codomain which are assigned with domain elements, right? This is not true, just I am drawing this way, right? So if you look at here, right, it means domain images means only the codomain elements which have assigned with domain elements, right? So it means you need to think about only the codomain elements which have relationship or which have assigned with the domain elements, right? Here we have 4 codomain elements, 2, 4, 9, 3. These are the 4 codomain elements. But if you think about the image, if you think about, let's say this is a function of h. So if you think about the images of h, we cannot write all the 4 codomain elements as a image, right? So images means we need to think about only which codomain elements assigned with the domain element. So this 2 is a codomain element which have assigned with the domain element 1. So we can write 2 is an image of 2. We can write 2 is the image of, so we can write 2 is the image of 1, right? Similarly, we can write 4 is the image of 4 is the image of -1 in the codomain. Similarly, 3 is the image of 0 and 3 is the image of 2, right? So the images are 2, 4, 3, right? We cannot include 9, right? Maybe for some different input variable, 9 also come, right? But for the specific set of inputs, we have what are the output elements assigned with the domain, then we can say those elements we can say as images, right? Here you even have more number of elements in the codomain. Only you need to think which elements assigned with the domain elements. These 3 elements are considered called as images of these function, right? So altogether, all these we can say the range of the function, right? So range of the function means it includes all the possible values for the function, right? Now I will move some important things, right? So first thing, if you draw a line or if you draw a graph, you need to find out whether it's a function or not, right? So these are the very important thing, right? First of all, if I draw a diagram this way, you need to find out whether this one is a function or not, right? How we can find out this one? One of the important key points says, right, let's say here, just I am writing for easiness English letters, right? A, B, C, D, 1, 2, 3, 4, right? The first important thing, right? This is domain, this is codomain, right? In the domain, all elements are assigned with the codomain. That is the important thing, right? If it is a function, right? So how we can find out if it is a function? If it is a function, all the domain elements have relation with codomain, right? So this is a function, right? So the first point says, right? The first point says all the domain elements, all the domain elements are assigned to a codomain element. So all the domain elements are assigned with the codomain element. So now you need to check all the domain elements A, B, C, D are assigned with the codomain element. So we can say this is a function, right? Now tell me, what about this one? What about this one? What about this one? What about this one? So first point says all the domain elements must be assigned with the codomain element. So that is the first point. So what do you think about this one? What do you think? Is it a function or not? So the first point says all the domain element must be assigned with the codomain element. So what do you think about this one? So this is domain, this is codomain. So what do you think? Is it a function or not? Tell me. So I already told you if it is a function, each and every element in the domain must be assigned with a codomain element. Right here, one is assigned with A is assigned with 1, B is assigned with 2, C is assigned with 3, D is assigned with 4. What about this one? Is it a function? This is not a function. Why? Why I am telling this is not a function? The domain element B is not assigned with any elements in the codomain, right? So it means in different way I can tell, right? All the domain elements must have an image, right? So here B is a domain element. They don't have any image, right? They are not assigned for any codomain element. So we cannot say, we can say this is not a function, right? We can say this is not a function, right? Why? The important thing you need to write the reason for that, right? So the B, right? B is a element of maybe domain. B is an element of domain. B is an element of domain, right? So maybe this is f of x is a function. So f of b is not a f of b. Then f of b is not assigned for any element in the codomain, right? So if it is a function, all the domain elements must assign with the codomain. If any elements missing to assign with the codomain, we can say that is not a function, right? That is the first important point. Okay, and that's first one, right? Second point, right? It is not mandatory to all the codomain elements are relation with the domain element, right? Previous case, all the domain element must be assigned with the codomain element, right? So you cannot miss any domain element. If any domain element is missing, we can say that is not a function, right? The vice versa, now they are saying it is not mandatory to all the codomain elements is assigned with the domain element, right? So now they are telling it is not mandatory to all the codomain elements, right? All the codomain elements, it is not mandatory all the codomain elements have relation with domain, right? So what it says, you can understand if I draw a diagram, right? So just look at here. This is my domain, right? This is my codomain. Right now they are telling here 1, 2, 3, right? Here A, B, C, D, right? Okay. So this is the point they are explaining, right? Now, if you look at here, in here, the codomain element B is not assigned with any domain element, but this is a function, right? This is they are telling. In the previous case, so if it is a function, to find out if it is a function, you need to check whether all the elements in the domain assigned with the codomain. Now it's correct, right? 1 is assigned with A, 2 is assigned with C, 3 is assigned with D, right? All the elements are assigned with codomain. So this is a first condition is checked. Okay, correct, right? Now we need to check the second condition they are telling. It is not mandatory to all the codomain elements are assigned with the domain, right? So here what will happen? B is a codomain element that is not assigned with any domain element. Even if it is not assigned with any domain element, we can say this is a function, right? That is the second point you need to remember, right? So if it is a function, all the domain element must be assigned with the codomain element, but it's not mandatory to all the codomain elements are have relation with the domain element, right? So if I ask you this type of graph, and I'm asking you whether it's a function or not, right? Then you can check with the domain elements. If all the domain elements are assigned, okay, now it's the first condition is okay. Another thing, it's not mandatory all the codomain elements are assigned with the domain element. So it is a function, right? So you need to easily find out the function in this way, right? So this is the second point, right? The third point, okay, the third point, says one domain element not linked with more than one codomain elements, right? Did you understand? One domain element cannot be relation with more than one codomain elements. Can you draw a graph for this one? So the third point says one domain element, one domain element cannot be relation with more than one codomain elements. Did you understand? One domain element cannot be relation with more than one codomain element. Right now, just look at here. This is my domain, right? This is my codomain, right? Here, A, B, C is there. Here, 1, 2, 3, 4, right? So this point says one is relation with this one, right? Also, one is relations with 3. This is not a function, right? So did you understand my point? So here what will happen? One domain element A. So the theory says one domain element cannot be relation with more than one codomain elements, right? Here what will happen? The element 1 have relation with the image 1, the codomain element 1 and codomain element 3. So we can say this is not a function. This is not a function. So that is the third point. So one domain element only relation with only one codomain element, right? We cannot relation one domain element cannot relation with more than one codomain elements, right? If they have this type of relation, we can say this is not a function, right? So first point I said all the domain element must have relation with the codomain. Second point, it is not mandatory to all the codomain elements. It is not mandatory to all the codomain elements have relation with the domain elements. Third point, one domain element cannot have relation with more than one codomain elements. Here what will happen? One domain element A assigned to two codomain elements, right? 1 and 3 are assigned. It is not possible. If we have one domain element, they have relation with only one codomain element, right? So the last point, it is related to codomain, right? So here one domain element don't have relation with more than one codomain elements. The fourth point they are saying one codomain element can possible with relation with more than one domain elements, right? So this is not a function, but if you look at the code, this is a domain, this is a codomain. So this is a domain, this is a codomain, right? Now here, A, B, C is there. Here, 1, 2, 3, 4 is there, right? The fourth point says, previous case, one domain element cannot have relation with more than one codomain element, right? but one codomain element have relation with two domain element, right? This is possible, right? So now this is a function, right? So now you need to check four condition, four elements, whether it's a function or not. So what is the first point? You need to check all the elements in the domain assigned with the codomain. So here all the elements are assigned with the codomain. That's the first point, right? Second point, it is not mandatory. All the codomain elements have a relation, right? So here, 2 is an element, right? It is not assigned with any domain element. So we can say it's possible, right? In the codomain, 2 and 4 are not assigned with any domain element. But in the second point, it is okay. We can, right? It's not mandatory. All the codomain elements have a relation with the domain. That's the second point. Third thing you need to check, is there any domain element have relation with more than one codomain elements, right? So in this scenario, so A only with one, B only with one, C only with one, right? So if I write this line, what will happen? One domain element have relation with more than one codomain element. So it's not possible, right? So then it is not considered as a function, right? This is not a considered as a function, right? So if I remove this one, so now the third condition is correct, right? Each element in the domain only have a relation with one codomain element, right? The fourth point they are telling it can possible one codomain element, one codomain element have relation with more than one domain elements, right? So that is the fourth point, right? So this is not possible. One domain element, it means one input have two outputs. It's not possible, right? One input domain elements means it's a one input have two output values. It is not possible. This is not a function, right? But if you look at here, two input have the same output. It is possible, right? Just think about f of x is equal to x squared, right? F of x is equal to x squared, right? Now, if I put x is equal to -1, what is the value of f of -1? So f of -1 is equal to 1, right? Similarly, if I put now if I put x is equal to 1, now what will happen? F of 1 is equal to 1, right? So now what will happen? Just imagine, right? In my domain, -1 is there. Okay, -2 is there. Okay, then 1 is there, 2 is there, right? Now what about my codomain? -1, 1, right? -2 to the power 2, 4, right? Now what will happen? My input -1 take this one, +1 also take this one, -2 take this one, +2 take this one, right? Now what will happen? Two input -2 and +2 have the same output 4. That is possible, right? But it cannot be possible one domain element have the relation with more than one codomain, right? It means one input have two different output. That is not possible. So these are the four conditions you need to check to find out whether it's a function or not, right? To find out whether it's a function or not, you need to worry about these four important aspects, right? So if you evaluate these 4 points to check whether it's a function or not, right? First, all the elements in the domain assigned with the codomain. It's not mandatory. All the codomain elements are assigned with the it's not mandatory. All the codomain elements are assigned with the domain, right? One domain element cannot be a relation with more than one codomain elements, but one codomain element relation with more than one domain element. So these are the 4 important points you need to remember to find out whether the given is a function or not, right? Okay. Uh, yeah, I will tell you something. I will share something, right? Then you can tell me the answer for this, right? Okay, now I think you are clear what is function and some basics, right? I think you can look at my screen, right? Yeah. Okay. Okay. Now just tell me the first one, second one, third one, fourth one, and fifth one. Now, can you tell me the answer for the first one? First one is a function or not? Tell me. First one is a function or not? Tell me which this is a function or not? What do you think? Answer my question. It's a function or not? What do you think? So based on the four explanation, can you tell me the answer? What about others? This is not a function, right? The first one is not a function. Why it is not a function? I need uh, I need the reason for each, right? So this is not a function. Yeah, it's correct. Why it's not a function? Tell me. Why is not a function? So if it is a function, all the elements in domain. So A is a domain, right? A is a domain. So here A is the domain, right? B is the codomain, right? So B is the codomain, right? So all the domain element must have assigned with the codomain. So first point is correct, right? But if you look at here, they are telling one domain element cannot have relation with more than one codomain element, right? So because of that condition, it is not a function. One domain element, one input cannot relation with more than one output. So because of that, it's not a function. So now tell me, what about the second one? So this is not a function, right? The first one is not a function. What about the second one? Second one, what do you think? So this is not a function. What about the second one? Tell me. So all the elements are domain assigned. It is not mandatory all the codomain elements assigned with the uh, domain. So second condition also correct. If you look at the third condition, is there is no any element in the domain assigned with more than one codomain element. So third condition also correct, right? The fourth condition, it's possible more than one domain element have the relation with one codomain element, right? So this is a function, right? So if you look at here, this is possible, right? Two input have the same output. The previous example, minus one, if f of x is equal to x squared, minus one is the input, it takes one, plus one is the input, it takes one, right? So this is possible. Both minus one is a minus one and plus one take the same output one. So this is a function, right? The second one is a function. How about the third one? Tell me the answer quickly. Uh, the important thing, the reasoning, right? If you clearly understand, then only you can give a correct reasoning. How about the third one? Third one, first condition is correct, right? All the elements in the domain assigned. It is not mandatory to all the elements in the codomain assigned with, right? So first two conditions are correct. So the third condition is correct, right? There is no any two input have the same output. Sorry, there is no two input values assigned with the, sorry, the third condition, there is no any domain element have relation with more than one codomain element. That is also correct. So now this is third one also a function, right? Yeah. What about fourth one? Fourth one, fourth one also a function, right? Fifth one also a function, right? So only the first one is not a function, right? So the important thing, if I give a diagram, you need to find out whether a function or not, right? That is important. Any questions? Any questions? Then I will move for the next one. Okay, now we will look at an example of a function, right? Okay, just think about they are telling f of x is a function is equal to x cube, right? So it means for x take real number as an input. So x always take real number. Then the function f of x also take the real number, real outputs, right? That is a common thing. If your inputs are real, always you are getting the output as a real number, right? So f of x is a x cube, that is a function, right? Okay, now this is a function, right? Now just, okay, I am writing some domains here, right? So this is, okay, this is A, right? This is B, right? Now I am writing here -1, 0, 1, 2, 3, right? So now these are my domain elements. Can you tell me what are the codomain of this function? Hmm? So my function f of x have five input elements: 0, -1, 0, 1, 2, 3. Can you tell me what are the codomains, or can you tell me what are the images of these? Hmm? So how you can answer? How you can write for here? So if my input, okay, the -1 is my domain elements, means in the function I can replace x is equal to -1, right? If I put x is equal to -1, so f of -1 is equal to what? -1 to the power of 3. So -1 to the power of 3 is equal to what? Minus into minus into minus minus. So -1. So here -1 is the codomain, right? Similarly, if I put f is equal to 0, x is equal to 0, then it is 0, right? So here this is a relation with this one. This is a relation with this one. So if I put 1, it becomes 1. If I put 2 here, 2 to the power 3, 8. If I put 3 here, 3 to the power 3, 27, right? So 3 to the power 3, 27. So this is the function, right? This way we can find out, right? Okay, the second thing, right, in the previous example, right, we have A is a set with A, B, C, D. There are 4 elements, right? B is a set, right? Just look at this diagram, right? Just look at this diagram, right? A with S, uh, B with U, C with R, so D with S, right? So if you have a function like this way, right? So A is a input, A is a domain element, B is a domain element, C is a domain element, D is a domain element. Now this is a function, right? This is F is a function, right? Now we can write F of A is equal to, F of A is equal to S, right? Then we can write F of B is equal to what? So f of B is equal to U, right? F of C is equal to R. F of D is equal to S. So these are some common things, right? Similarly, previous case, f of -1 is equal to -1. F of 0 is equal to 0. F of 1 is equal to 1. F of 2 is equal to 8. F of 3 is equal to 27. Similarly, we can write for alphabet as well, right? So if you look at this diagram, right now, can you tell me what are the images here? So can you tell me the images of this function f? Images of this function f, we cannot write all 4, right? So images means which are the, which codomain element have relation with domain elements, they are considered. So this codomain element R have a relation with C, domain element C. Similarly, S have a relation with A and D. Similarly, U is the codomain element have relation with B, right? So the images are R, S, and U, right? We cannot write T because the codomain element T is not have a relation with any domain element. So we can say the images of the function is R, S, U. There is no T will come, right? Okay, the next one, identity function, right? The next one, there is a special function called identity function. There is a special type of function called identity function, right? I will tell you what is identity function, right? The identity function means, let's say there is A is a set, right? They have 1, 2, 3, 4. There are 4 elements in the set, right? So if I write a function from A to A, this is, sorry, from A to A, this is called identity function, right? So it means my domain elements are from A, my codomain elements are also from A. So this type of function we can call codomain function. The previous case we are writing function f, A to B, right? A is a different set, B is a different set, right? A is a domain, B is a codomain, but A and B are two different sets, right? Now, if you look at here, the identity function, domain and codomain have the same set, right? So if you look at A have these 4 elements, right? So if I write a function this way, I just look at here. This is domain. Domain also contain the elements from 1, 2, 3, 4, right? Codomain also contain elements from 1, 2, 3, 4, right? This type of function we can call identity function, right? So this type of function we can call identity function. We can write the identity function as a 1a, right? If you look at here 1a, so this is an identity function, right? So it means all the elements of A. So maybe we can write this way, or maybe we can write 1a. So if I write this way, this is also indicate that it's an identity function, right? So it means the domain and codomain element have the same element. Domain and codomain have same elements. Input and outputs are same. Okay. It means it is not this way. 1 to 1, 2 to 2, 3 to 3, 4 to 4. It is not always becomes this way, right? It is also a one-to-one function, right? This is not only true, right? If I draw this way, if you look at here, okay, what do you think now? What do you think now? Is it a function or not? Is it a one-to-one function? It is a identity function or not? What do you think? Now just think about this is a G, right? So what do you think? A to A. Is it A to A? Is it a function? What do you think? A to A? For that scenario, you need to check the 4 important aspects of the function, right? So here, all the elements in the domain assigned with the codomain, right? All the elements are, there is no element remaining in the domain empty, right? All the elements in the domain assigned with the image codomain, right? So first point correct. Here, it is not mandatory all the codomain elements assigned with the domain. So second point also okay. Third point, what they are saying, there is no one domain element cannot have relation with 2 codomain elements. That is also true, right? But one codomain element have a relation with more than one domain element. So this is a function, right? This is also considered one-to-one function. This is not only one-to-one function, right? This is also a one-to-one function. But here, if you look at here, the element 4 is not assigned, right? But this is a function, right? This is a one-to-one function. So don't think if it is a identity function. If it is identity function, always it consider this way, right? This one also identity function. Why? First of all, it will satisfy the condition for the functions, right? Then we cannot say all the elements in the we can say all the elements in the codomain. It is not mandatory they are assigned with the domain, right? But also one codomain element have the relation with more than one domain element. So this is also a identity function, right? Any questions? So this one also an identity function, right? This is also an identity function. This is also an identity function. The this example, right? 1, 2, 3, 4. Here also 1, 2, 3, 4 is there, right? But if I wrote this way, what will happen? This is not a function, right? Because one domain element cannot have a relation with more than one codomain elements, right? This is possible, right? So here 4 is not assigned with any elements, but it is a identity function. But even if it is a identity function, right? So we can write identity function as a f of b to b or whatever, the same letters. Or maybe we can write identity function as a, if I write 1, then if I write b, this is also indicate that is a identity function. Even if I mention this way or this way, you can understand it is a identity function, right? Okay. Yeah. The next topic is a relation, right? The next topics we are discussed as a relations, right? So functions have some uh, similarities with relations, right? So functions mean the relationship between the variables, right? Yeah. Someone asked why we are using G symbol, right? To indicate functions, not always we are using F only, right? So if f of x is equal to x squared or x cube, this is a function, right? It is not mandatory I'm always use F to indicate a function, right? Maybe I can use this letter as well. G of x is equal to x cube. This is also same, right? Not only G, right? I can use h of x cube. All are correct, right? We can use different letters, different lowercase letters to indicate the function, right? Maybe I can use e of x, right? So within this bracket, that is the variable. That is a variable, the changeable value, right? So now if I write h of t, so it means what? H of t means this is a function. What is the variable here? So the function, if I write this way, is it correct? H of t is equal to x cube. Is it correct? It's wrong, right? It's wrong. If I write h of t, so within the bracket, I'm telling you t is my variable. So I need to change the function as a t cube or something likewise, right? So if I write pi of x, then x cube is okay, right? So I can use different letters to indicate the function, right? It's not mandatory to use always f, right? So if you look at this form, right, maybe maybe you can look at h of x, right? This is a function. The variable is x is the variable. So if I change the value for x, the function will take different value. So h is my variable, right? So maybe we can write x squared minus 5, right? Similarly, I can write h of t, then t squared minus 5, right? Depending on the variable I am mentioning here, my function must be in that variable, right? If I write h of t is equal to x squared minus 5, it is wrong, right? So if I write this way, it indicates t is my variable. So definitely I cannot put x here. Always it becomes a t, is t squared minus 5, right? Just think about that one. Okay. Okay, our next topic is relations, right? So the functions have equal things in the relations as well, right? Function and relation have some similarities, right? They have some relations, right? Even the functions we can denote it by using the relations, right? So maybe next class we will discuss the relation, right? So the relations are defined the pairs of elements, right? So in the relation, we will define elements as a pair, right? We are define the elements as a we will define the elements as a pairs in the function, right? So A comma B. So this is a relation. So the A and B are two elements, right? Now what will happen? We can define function as a relations. So up to now we are discussing functions. So we can define functions as a relations as well, right? So relation means they have, we can write elements as a pairs, A comma B, right? If I convert function into relation, the first element is the domain element. The second element is the codomain element, right? So this is the, if we convert functions into relation, right? So the first element in the function, domain element, the second element is the codomain element. So another point of view, we can define the functions as a relations, right? So we know function f a into b, right? This is equal to relation from a to b. So we can call graph of function. So we can discuss those things. We are looking at the relations, right? So in the relation, we will define element as a pairs, right? So relation, we are define the elements as a pairs, right? The first element and second element. So if I explain function as a relation, I need to put first element as a domain element, second element as a codomain element, right? If I explain with the diagram, you can easily understand, right? Just look at here. The previous case, we have a domain and codomain, right? This is my domain, this is my codomain, right? Here, A, B, C. It's not a function, right? Sorry. Okay. Now we already know this is a function, right? F is a function, right? Now we know maybe this is D. Okay. I'm putting this is C, right? So then I can write F is a function from D into C. Function D to C, right? So if I write this function as a relation, if I write this function as a relation, I already told you in the relation, we can write as a pairs of element, right? Now we can pair A and 1 is a one pair, right? B and 2 is another pair. C and 2 is another pair. So we can denote this function in a relation on this way, right? Only three pairs, right? Maybe if you have another element D, maybe you can put this one here, or maybe I can write this one here. Then my relation is increased into comma D and 3, right? So this is my relation, right? So if you look at here, so this is a relation, right? So relation means the first element is a domain element. So domain element, this is a domain element, this is a domain element, this is a domain element. The next second element is the codomain element, right? So now what I'm telling here, if I give a function, you can convert that function into relation. Or if you have a relation, then you can draw this diagram. From this one, you can draw this diagram. Also from this diagram, you can write the relation. Both are possible, right? So they are explaining those things here. Okay, I will explain with an example. Just look at here. Okay, just look at here, right? There is a function from A to B. Okay, yeah, they are explained with that previous example, right? That previous example means this diagram, right? Now, can you convert this function into relation? This is a function, right? Can you convert this function into relation? Try yourself how to convert this function into relation, right? If I write the function as a relation, right, I need to write the elements as a pair, right? The first element is the in the domain element. Domain element is A, comma, my codomain element is A and S, comma, second element, my domain element B and U, right? So B is my domain element, U is my codomain element. Then C and R, third pair. The last pair is D and S. So this is the way we can write a function in the relation, right? In the relation, we are writing element as a pairs, right? So the first element is a domain element. The second element is the codomain in the pair. On that way, we will write or we will convert functions into relation, right? So if you look at here, so A and S, right? A and S is my first one. B and U, the second one, B and U, BU. So likewise, we will write functions into relation, right? Okay, the second example, if you look at here, right? There is a set A. A is a set with three elements, 1, 2, and 3. These are the elements of A, right? They are giving three functions. F is a one function, G is another function, H is another function. Also, they are telling this function A is a, if they are telling set A, they have three elements. 1, 2, 3 is the element, right? Then they are telling these functions are identity functions, right? So in this question, they are telling f is a function from A into A. So A into A means that is a identical function, right? That is a identical function. So A into A means that is a identical function, right? So in this question, they are mentioning this function as a relation, right? From this relation, you need to draw the graph. Can you draw the graph from this relation? Can you draw the graph? Can you draw the function graph? So also they are telling this is an identical function, right? So if it is an identical function, we know the common thing, right? Domain and codomain have the same element. 1, 2, 3 is the element for the domain. Also 1, 2, 3 is the element for the codomain. Because already they are mentioning A is a set. They have three elements, right? Now they are telling a function, right? F is a function, right? F is a function. Then they are telling 1 and 3 is a one pair. 1 and 3 is a one pair. So this one is what? This is a domain element. This one is a domain element. This domain element 1 have relation with, this is a codomain element 3. So we can draw this way, right? If you look at the second pair, now what will happen? Domain element 2, codomain element is also, this is also 3. If you look at the third one, domain element 3 has relation with 1, right? Now, what do you think? If f is a function or not? Tell me. F is a function, right? Why I am telling f is a function? F is a function. Why F is a function? All the domain element have relation with codomain element. It's not mandatory all the codomain element have relation with the domain, right? Also, one codomain element have relation with more than one domain elements, but there is no one domain element with relation with more than one codomain element. So F is a function, right? So we can say that from this relation, from the relation they are telling, we can say f is a function. Similarly, can you draw the function graph for g? How to draw the function graph for g? So this is a function. So how you can write for g? So g also we have the same, g also identical function, right? From g also from a to a into a, right? So here 1, 2, 3, domain have 1, 2, 3, codomain have 1, 2, 3. So here the first in the relation, first element is the domain element. So 1 to 2. The next one, domain element 3 relation with 1, right? Now can you tell me whether g is a function or not? G is not a function. Why? G is not a function. Why? 2 is an element of the domain. They are not have any relation, right? But the important uh, theory says all the elements in the domain have relation with the codomain. But here, 2 is a element of the domain. They are not relation with any other codomain element. So G is not a function, right? So this is the way we can find out whether it's a function or not, right? Maybe they are giving in the function or in the relation form, right? Now they are telling H is a function, right? So H1 also a identical function from A to A, right? H also a identical function from A to A, right? Then we can draw this one, 1, 2, 3. Here we can draw 1, 2, 3, right? So if you look at here, so the one domain element 1 have relation with 3, right? Domain element 2 have relation with 1. Domain element 1 have relation with 2. Domain 3 have relation with 1, right? Now tell me, is it a function or not? This is not a function. Why? This is not a function. Why? One domain element cannot have relation with more than one codomain element. So because of that, H is not a function. So this is the way we can find out the functions, right? So even we can write functions in the form of relations as well, right? Okay, the next thing, composition functions, right? Give me another 15 minutes. I will finish everything, right? So the next one, composition function, right? So the composition function means, let's imagine you have a function f from A to B, right? You have a function from f. F is a function from A to B, right? So A is a domain, B is the codomain, right? You have another function G, B into C, right? So if you have a function f A to B, another function G, B to C, right? If you have, it means A is the domain, right? B is the codomain, right? So the first function f, the codomain B, consider as a domain for the second function G. So here the codomain of function f consider as a domain in the function G, right? Then we can say these two functions, we can write composition function, right? To write the composition function, we can write G of f, right? For the composition function, we can write G of f A to C, right? So this is similar to the previous one, right? A plus B plus C is this way, right? A plus B plus C is equal to A plus B plus C. Likewise, right? The composition means you have two functions. F of A to B is A into B is a one function. G of B to C is another function. So we can write. So the important thing, the domain of the codomain of first function is the domain for the second function. That is the condition, right? So the codomain of the first function considers a domain for the second function. Then we can say this is a composition of functions, right? So composition of function, we can write G of f from A to C, right? So A to B is a function, B to C is another function. Then we can find out A to C as a function. That is, we can call composition of function, right? So the composition of function, we can write G, sorry, g of f into a is equal to g of f of a, right? You can understand what is this if you look at an example, right? So this is the thing. So what they are telling here, right? Just imagine, right? You have a set A, right? You have a set A, you have another set B, right? A have element A, B, C, right? Here, maybe we can say, let's say this is a function f, right? Here, what will happen? F of A, maybe f of B, f of C, right? So this is f of A, this is f of B, this is f of C. Another function. Now, in this function f, B is the codomain. Now, in the function G, B considers a domain, right? Now, what will happen here? G of f of A, right? G of f of B. Here, G of f of C, right? So these are the So this is C, right? So these are the function of G, right? This way. Now we can say as a function from A to C, right? So this is we can call composition function. From A to B is a function, B to C is another function. Then we can write A to C is a function. That is composition, right? You have a function A to B, another function B to C. Then you can say A to C is A into C is a function. That is a composition of function. We can write composition of function G of F, right? The second function first function second, right? So it is equal to G of F of X, right? Or G of F of X or G of F of A, right? So if you need to understand, just read these. They are explaining here well, right? So we find the image of A under F. In the function F, there is an input A. For the input A, we have an image that is codomain element, F of A, right? Now, this F of A is a domain for the second function, G. Then we can say G of F of A. That is the image of F of A in the function G, right? Okay, now just look at here. There is a function A to B, right? Now, can you tell me this one? What is this? F of 1A. F of 1A means, so 1A means what? 1A means that is a function from A to A, right? I think if 1A means that is an identical function from A to A, right? Now, what they need to find out here, we have a function from A to A into A, right? And another function, okay, maybe I am telling here G, right? G is a function from A to A. This is my first function. Another function F from A to B. Then they are asking F of G. G means F of 1A, F of 1A. Or maybe we can write for this one, I can write this one, F of G. Now tell me, what is the answer for this one? Hmm? So if you look at here, my first function is A to A. My second function is A to B. So the first function codomain A considers a domain for my second function. Now what will the answer for my if I composition these two functions, what is the answer? So just look at here, A to B, B to C, then we are getting a function from A to C. Similarly, A to A to B, then the function from A to B, right? So the function is F. So we are getting A to B as a function, right? So that is the already given function. So they are telling this is F, right? Is equal to F, is equal to this function, right? Similarly, they are telling another point, right? So now if you look at here, this one, so okay, 1b. 1b means one. 1b means that is something a function h, right? So 1b means a function h from b to b, right? Similarly, here f is a function already know, right? So if I need to find out 1b of f, so this is a one function, this is one function, right? So for that one, first I need to take my second function, right? So my second function first, right? So my first function f is equal to a to b, right? My second function, maybe h is equal to b to b, right? Now they are asking f of, now they are asking 1b of f. So now what will happen? I am getting a to b, right? So a to b, b to b, then I am getting a function from a to b, right? Now I am getting a function from a to b. There is nothing, right? You have a function a to b. So the important thing, the codomain of the first function considers the domain for the second function. Then I can write a function from a to c. That is, sorry, a to c. That is the composition function, right? They are explaining by this one, right? Okay, this is the last one, right? There are three type of functions: one-to-one function, on-to function, and inverse function. These are the three different function types we are discussing. That's all the theory, right? Okay, now I will tell you what do you mean by uh, one-to-one function and in on-to function and invertible functions, right?